What's up, herb nerds? It's your herb daddy. Next in the alphabet is B for berberine. It's a pretty cool molecule. This is a big one, so strap in for the ride. The amount of clinical evidence for berberine is growing every month, and it continues to show impressive results in metabolic and cholesterol pathologies, as well as some pretty shocking results in colorectal cancer. We'll get to all of that in a minute, but first we need to talk about where it comes from and the chemistry of berberine. Berberine gets its name from Berberis, the genus of plants which are quite abundant with berberine. Here in the western US, the easiest way to meet berberine is to find this plant, Oregon grape, Mahonia aquifolium, or now Berberis aquifolium. I honestly prefer the old name, but botanists need jobs too. There are quite a few Mahonia species here in the western US, so it's pretty easy to find one out in the wild. In other parts of the world, you may have a better luck finding good old Berberis or barberry, because it is a commonly planted shrub. There's a good chance it's in the landscaping of a parking lot near you. Typically, the roots contain the highest amounts of berberine, and that's what you'll find in commerce. If you get some root and scrape off the bark, you'll see the characteristic yellow color of the berberine and related compounds. The aerial parts also contain a fair amount. If you cut off a stem and slice off the outer bark, you'll see more of that characteristic yellow color. In Mahonia, the stem contains about 0.3% berberine. The roots are typically over 1%. In barberry, the root can contain up to 8% berberine. Traditionally, Mahonia and Berberis are mostly used to support liver and skin issues, acne, psoriasis, and eczema. The thought here is that they help to stimulate the skin and liver metabolism so that the body can clear metabolic wastes and thus take some of the pressures off these two tissues. Indeed, we do see that berberine protects the liver and kidneys in preclinical and clinical research, so there could be an increase in processing and removal of waste material. However, when dealing with whole plants, it's important not to be too reductionistic. Yes, Berberis contains berberine, but it also contains hundreds of other constituents that are doing their own thing, and each one of them is modifying the other's activity. It's the beauty of herbalism. Just remember, using Berberis plants is not the same as taking pure berberine. In traditional lingo, Berberis is said to stimulate internal and external secretions and is good for dry and congested tissue states. If you wake up with bad breath and a white or yellow coated tongue, have thick mucus that gets stuck rather than lubricates, and have a tendency towards skin eruptions, allergies, and hormonal issues, then Berberis might be something to try. Along those same lines, Berberis plants are excellent digestive bitters and help to improve digestion, especially fat digestion. 5 to 20 drops of a tincture taken before a meal can help start digestive secretions and improve the digestive process. The third common use of Berberis is as an antimicrobial. While they definitely are antimicrobial and berberine plays a role here, it's somewhat selective about what it kills. Modern research shows that berberine has a mixed effect, meaning it works through various mechanisms, but it doesn't work against all bacteria, which is probably good for our gut. Whole plant extracts are going to be much more effective than purified berberine because they will have all those other constituents working in concert to really knock down the organism. Traditionally, Berberis was commonly used to treat skin and GI infections, which makes sense because, as you'll learn, the protoberberine alkaloids don't absorb into the body super well. In modern research, we see some positive results with Berberis and MRSA, especially when berberine is combined with antibiotics. Some folks will even use Berberis to treat their water and help prevent giardia when in the wilderness, which I suppose could work in a pinch, but we have really good filter technology now, so there are better options. While Berberis may not be a potent antibiotic, it has been shown to boost other antibiotics, probably by inhibiting or downregulating efflux pumps. Efflux pumps help bacteria to spit out the antibiotic before it kills the bacteria. Just like I mentioned with MRSA, there's also some interesting research that showed that adding berberine to triple antibiotic therapy to treat ulcers with H. pylori infections was much more effective than antibiotics alone. Bottom line, don't expect full antibiotic effects from Berberis, but it can help in a pinch and may certainly be worth adding to an antibiotic regimen to help increase their efficacy. Either way, get out and look for Mahonia or Berberis in your neighborhood. See if you can see and maybe taste the berberine. But now let's talk about its chemistry. Berberine is the first alkaloid in our alphabet of constituents, so let's talk a little about alkaloids. Alkaloids are very interesting compounds, and depending on who you talk to, the definition of an alkaloid will change a little bit. For me, this is my definition of an alkaloid. An alkaloid is a nitrogen-containing constituent built from an amino acid in which the nitrogen occurs in a heterocyclic ring in its final structure. So here with berberine, we see the nitrogen here, and it's in a ring. That is my definition of a true alkaloid. There are variations such as the protoalkaloid, in which the nitrogen doesn't occur in a ring in the final structure, and also a pseudoalkaloid, which contains nitrogen, but the nitrogen doesn't come from amino acids or is added later in the biosynthesis process through amination. All of that's getting a little bit into the weeds. It can be difficult to tease out what type of alkaloid you have just by looking at the structure. So these definitions are really for the medicinal chemists and pharmacognosists out there. But for now, let's just focus on the important parts. Alkaloids are produced by organisms. You and I produce alkaloids, and they contain a nitrogen. This nitrogen comes from amino acids, and so another way that we can categorize alkaloids is by the amino acid that they start from, or by common structural themes that we observe in alkaloids. Alkaloids tend to be quite bitter, and they have some unique solubility properties in that their solubility changes depending on the pH of the solution. I'll have to make a separate video all about alkaloids so we can dive into that. In the case of berberine, the starting point for its biosynthesis is tyrosine. Tyrosine is converted into dopamine, and then through some plant chemistry magic ends up with a benzyl isoquinoline core structure. So this is berberine's main classification. The benzyl isoquinoline alkaloids are a rather important group of alkaloids and include some pretty hard hitters, such as morphine, codeine, reticuline, papaverine, and tubocurarine, the paralyzing poison in arrow poisons. Within the benzyl isoquinoline family of alkaloids, berberine is in the protoberberine subclass. Shocker. Other alkaloids in this subclass include berbamine, coptacine, palmitine, and tetrahydropalmitine. So let's recap. Berberine is a true alkaloid derived from tyrosine in the benzyl isoquinoline class and protoberberine subclass of alkaloids. Phew! So how does knowing all that help? Well, it helps us to know what the core structure of berberine is. We know it's going to contain a nitrogen in a ring, and that it's going to have a benzyl isoquinoline core as its structure. Finally, being in the protoberberine subclass tells us that it has a fourth ring, and that the nitrogen is a quaternary amine. This last little nugget is quite important to the properties of berberine. A quaternary amine means that the nitrogen has 4 bonds to carbon atoms. If you remember back from general or organic chemistry, you may recall that nitrogen tends to prefer 3 bonds based on its electron structure. In the right situations, however, nitrogen can be convinced to share its last pair of electrons to form a 4th bond. This, however, does something critical. It makes the nitrogen a cation. So berberine with this quaternary amine is a positively charged molecule, an ion. This has very significant consequences for berberine as a medicinal compound. 1, it makes berberine water soluble. And 2, it makes it very difficult for us to absorb berberine into our bodies because big bulky ions don't easily move across our cell membranes. We'll come back to this in a bit. All right, one last thing to know about berberine before we move on to its medicinal properties. Most alkaloids are colorless, but berberine is a bit special. Its particular structure gives it an intense yellow color, as we saw in Oregon grape. This makes it pretty easy to spot out in the plant kingdom. Plant tissues that are rich in berberine will have a yellow color. We especially see this in the roots of plants that contain berberine, such as Berberis and Mahonia, Coptis, aka golden thread, and Hydrastis, aka golden seal. Notice the golden. I should say, however, that there are other yellow plant compounds, so just because you find a yellow root doesn't guarantee it has berberine in it. Okay, finally on to the medicinal actions of berberine. As I said, we have many levels of evidence to support the medicinal activity of berberine, and most importantly, berberine has piles of human clinical data. This is a constituent that we know works in the human body, and it can do some pretty cool stuff. With that in mind, I'm going to primarily stick to the clinically validated information for berberine. As usual, there are a couple of pathways I think it's important to know when talking about berberine. In the case of berberine, the pathways I want to talk about are AMPK and PCSK9. If you're a bacteria, kudos for watching YouTube, by the way, then we already mentioned efflux pumps, which are important too. AMPK, or AMP-activated protein kinase, is one of our main metabolic regulating pathways. Our cells carefully monitor the amount of ADP and AMP in relation to ATP to determine the overall energy status of the cell. Remember that ATP is the main energy currency of our biochemistry. If a chemical reaction needs energy, there's a good chance that ATP will be used to make it happen. When the amount of ADP or AMP starts to increase in relation to ATP, this is a big signal that the cell needs to switch focus to make more ATP so that it can stay functioning. This is when AMPK steps in. AMPK is a highly conserved and critical pathway for pretty much all eukaryotes, so we know it's a big deal. Once activated, AMPK turns on certain pathways and turns off others through phosphorylation. It's a kinase. Kinases add phosphates to enzymes or molecules to change their functions. The result of AMPK's phosphorylating is a shift in the cell's activity towards taking in fuel, glucose and lipids, and converting it into energy, ATP. In other words, it switches cells into a catabolic state rather than an anabolic state. Glycolysis and mitochondrial oxidative metabolism are increased, while gluconeogenesis and lipogenesis are decreased. Again, use fuel rather than make more. Cholesterol synthesis is also dialed down a little bit. Cell growth machinery is decreased by inhibition of mTORC1, less building, more burning, and prolonged activation of AMPK promotes autophagy, the removal of dysfunctional mitochondria and other organelles, and increases mitochondria biogenesis, the making of new mitochondria. This improves metabolic efficiency and decreases reactive oxygen species production. Old mitochondria are a bit janky and can spit off more free radicals, so it's best if we remove them and replace them with the latest model. Now that we understand AMPK a bit better, how does berberine fit in? Well, berberine is an activator of AMPK. We believe it does this by inhibiting complex 1 in the mitochondrial electron transport chain. This results in a drop in ATP production, and voila, AMPK is switched on. And the cell switches to catabolism to accommodate. Remember, most of the ATP in our cells is made in the mitochondria through oxidative phosphorylation. At this point, you're probably expecting me to say powerhouse of the cell. Oops, now I've said it. But yes, berberine is slowing down the powerhouse of the cell. So less ATP can be made, and this is a big stimulus for AMPK activation. Part of the reason this happens is because of berberine structure. See, all that chemistry matters. Its positive charge means it's attracted to the mitochondrial matrix, which has a negative charge, because the mitochondria is busy pumping protons into the intermembrane space in order to make ATP. Hopefully you remember that from biochemistry. So berberine concentrates in the mitochondrial matrix and inhibits complex 1. This is actually similar to one of the proposed mechanisms of another positively charged metabolically regulating drug, metformin. We actually see a lot of similarities between metformin and berberine, and as we'll see, they actually play pretty well together. Another potential mechanism of AMPK activation is inhibition of PTP1B, protein tyrosine phosphatase 1B, which is important on its own as a regulator of insulin signaling. When active, it suppresses the insulin response substrate and prevents the downstream effects of insulin, such as opening up the cell to glucose. PTP1B also acts as an off switch for AMPK. So when berberine inhibits PTP1B, it improves insulin sensitivity and opens up all the potential effects of AMPK activation. In human cell models, we see very significant PTP1 inhibition with berberine. Depending on the tissue, there may be other targets than the AMPK pathway, but a lot of that is based on preclinical models, and I don't want to get too into the weeds. Still, there are other important downstream effects of AMPK I want to mention. First is SIRT1 activation. SIRT1 stands for sirtuin-1. This occurs when the amount of NAD+ increases in the cell as a consequence of AMPK turning on certain pathways. SIRT1 is significant because it also modulates multiple pathways that influence mitochondrial biogenesis, inflammation, stress response, and metabolic control. It even further promotes AMPK activation. So a lot of the positive therapeutic effects of berberine may be due to SIRT1 activation. AMPK and SIRT1 go on to activate PGC1 alpha. This one's a mouthful. Peroxisome proliferator activated receptor gamma coactivator 1 alpha, which is a transcription factor which supports a lot of the effects we've been talking about. Okay, one more time because that is a lot to take in. Berberine concentrates in the mitochondrial matrix, and this inhibits complex 1. This leads to a drop in ATP production and activation of AMPK. Elsewhere in the cell, berberine is inhibiting PTP1B, and this causes the cell to be more sensitive to insulin and also leads to more AMPK activation. AMPK puts the cell into a catabolic state, and so it starts to consume fuel. This leads to an increase in NAD+, which triggers the activation of SIRT1, which activates additional stress response and metabolic control pathways. Prolonged activation of both AMPK and SIRT1 lead to the activation of PGC1 alpha, which is a master regulator of mitochondrial biogenesis and energy and stress response. All of this leads to a cellular state that is ultimately more efficient at bringing in fuel and utilizing it for energy. The cell is less inflamed and better able to respond to stress stimuli. Additionally, if the cell was cancerous or precancerous, activation of these pathways can result in their destruction through apoptosis. Okay, we need a break from biochemistry. Let's talk some clinical results. This is where it gets interesting. In clinical research involving berberine, we see pretty remarkable shifts in metabolic disease, consistent with AMPK activation, PTP1B inhibition, and SIRT1 activation. A meta-analysis including 46 studies and up to 4,000 participants showed that berberine, both alone and in combination with drugs to manage type 2 diabetes, like metformin, significantly reduced fasting blood glucose, HbA1c, postprandial glucose, and improved markers for insulin sensitivity. Berberine performed almost as well as Western pharmaceuticals, but it did quite well against placebo, and perhaps even more exciting, it did extremely well when given with pharmaceuticals, showing a strong additive effect. Since having a meta-analysis on plant constituents is pretty rare, let's take a moment to look at this data. Bear with me, I think it will be worth it for you. This is the typical output of a meta-analysis, and it's called a forest plot because these look like little trees. On the left here, you'll see all the different studies that were included in the meta-analysis with the corresponding data, and this is distilled into these lines. So the lines represent the confidence interval of each study, with the center of the line being the mean or average. At the bottom, you'll see a little diamond, and that represents kind of the collective average of all the studies that were included in that particular analysis. One thing to note about these forest plots is that they have this center line. That's called the no effect line. If any part of the data, the line or the diamond, touches that no effect line, then that means that there's no statistical difference between the treatment and the control. If the line lies on the left, usually, sometimes it's opposite, but if all of the line lies on the left of the no effect line, we say that the study favors the treatment, and if it lies completely on the right here, we say it favors control. So again, if any of the line touches this no effect line, statistically, there's no difference between treatment and control. The left favors treatment, the right favors control. And again, sometimes that can switch. So looking at the data from this particular study, on this chart, we're going to look at HbA1c and fasting glucose first. We have the data set up into 3 different comparisons. The top here is berberine versus drugs used to treat diabetes, type 2 diabetes. So berberine versus pharmaceuticals. The second grouping is berberine versus placebo. So berberine versus no treatment, basically. And then the last largest grouping here is berberine combined with pharmaceuticals versus pharmaceuticals alone. So let's quickly go through this. With HbA1c and fasting glucose, we see that the finalized data point here shows that the diamond is touching the no effect line. So we don't really see a clear statistical difference between berberine and the drugs that are commonly used to treat type 2 diabetes. The drugs maybe irk out a little bit more of a response, but again, it's not statistically significant. Against a placebo, berberine fares quite well, and we see about a 0.38% drop in HbA1c and about a 10-point drop in fasting glucose in people just taking berberine and nothing else. Even more impressive is when we combine berberine with pharmaceuticals. So people taking metformin or other type 2 diabetes drugs put berberine on top of that regimen, and we see an additional almost full percent drop in HbA1c and a almost 20-point drop in fasting glucose. Those are pretty impressive results. So the diamond here at the very bottom is kind of the collective response, and we see, yes, berberine definitely had a statistically relevant decrease in HbA1c and fasting glucose in all the studies tested. Similar story with postprandial glucose. So these are patients that took a big bolus of glucose, and then we measured their blood sugar 2 hours later. And basically same thing, berberine versus pharmaceuticals. Pharmaceuticals did a little bit better, but the diamond's just barely touching the no effect line, so we'd say they're not statistically different. Berberine versus placebo did quite well. Again, berberine kept the blood glucose down by about 27 points. And when we gave berberine with the common drugs used to treat type 2 diabetes, again, it added an additional 24.1 point drop in blood sugar. Some of the studies also measured these other endpoints, so fasting plasma insulin. And again, collectively with all the studies, we see that berberine dropped insulin by about 2 micro IUs. The kind of classic measure for insulin resistance is the HOMA-IR. And again, we saw a statistical drop in that with berberine across all these studies. And even BMI. So BMI dropped by about 1.43 if we look at all the studies collectively. So again, very impressive results for berberine. For me, all of this data suggests there are 2 very promising areas where berberine could be used. First, in pre-diabetic individuals that are showing some metabolic dysregulation, but it's not quite to the point where we feel like we need drugs. Adding berberine or berberine-containing plants could help turn things around and prevent them from developing diabetes, along with lifestyle and diet modifications, obviously. And second, in individuals with type 2 diabetes that aren't quite getting the impact they need from their current drug regimen. Perhaps adding berberine to their protocols could improve their metabolic control and give them more time before they become insulin dependent or, hopefully, prevent it outright. Another therapeutic side of berberine centers around cholesterol and triglycerides, where berberine consistently shows a lowering of LDL, total cholesterol, and triglycerides, with some studies also showing a slight bump in HDL. AMPK and the downstream activation of PGC1 alpha is definitely implicated here, but we also see another potential player, PCSK9, proprotein convertase subtilisin kexin type 9. This is a target for newer cholesterol-lowering drugs like evolocumab, alirocumab, and enlicitide, but preclinical data also shows that berberine could be influencing this pathway. PCSK9 is a protein made by the liver that latches on to LDL receptors, also on the liver, and tags them for degradation. This means if you have high PCSK9, you will have a low amount of LDL receptors on your liver, and therefore LDL cholesterol will stay circulating in your blood longer, i.e., high PCSK9 means you will have high LDL. If we can decrease the amount of PCSK9, then your liver will keep those LDL receptors active and continue to pull LDL out of your blood. The cholesterol can then be recycled or excreted. Human liver cells and some animal studies have shown decreased expression of PCSK9 after treatment with berberine. In human liver cells, berberine decreased PCSK9 through the HNF1 alpha pathway. HNF1 alpha is a transcription factor that promotes the production of PCSK9. More PCSK9 results in less LDL receptors and more LDL cholesterol in the blood. Berberine has been shown to increase the degradation of HNF1 alpha by activating the ubiquitin proteasome system. So, less HNF1 alpha means less PCSK9, and that means more hungry LDL receptors on the surface of the liver cells, and ultimately less circulating LDL cholesterol. Clear as mud. At this time, we're not sure what the actual target is that causes increased proteasome activity and degradation of HNF1 alpha, but we see increased proteasomal activity with berberine in several models that causes a shift in several pathways, and this may be one of the mechanisms for berberine's effect on some cancers. We'll get to that in a minute. Clinically, there is strong evidence for berberine's effect on cholesterol. The meta-analysis we talked about earlier in type 2 diabetes patients, berberine treatment lowered total cholesterol, LDL cholesterol, and triglycerides, and showed a little increase in HDL. This was confirmed in a different meta-analysis looking at 2,147 patients with type 2 diabetes, prediabetes, carotid atherosclerosis, or coronary artery disease. Let's have a quick look at that data. So this first study, this is again the type 2 diabetes study, looking at triglycerides, total cholesterol, HDL, and LDL. And again, we see a clear drop in triglycerides. We see total cholesterol drops with berberine by about 24 points. HDL increased it a little bit in this study, 6.2 milligrams per deciliter. And it was significant in this study. And LDL dropped a whopping 32.5 points with berberine. In the second study, again, these include other disease pathologies like prediabetes, carotid atherosclerosis, coronary artery disease, etc. And again, we see very similar results. So triglycerides dropped, total cholesterol dropped by about 18 points. LDL increased in this study, not as much, and it wasn't really significant, but still a slight increase. And LDL, again, not as pronounced decrease, 14.7 points, but still a significant decrease when all of the data was parsed together. Berberine is not likely to replace statins, but the fact that it decreases cholesterol along with all its metabolic effects makes berberine a very promising compound in the diseases of our time, diabetes and cardiovascular disease. Combination of berberine with statins did show an additive effect because berberine and statins work through separate pathways. Unfortunately, berberine has some drug interactions and can increase the uptake and/or decrease the metabolism of some statins, thus increasing the chance of statin side effects. So this is a combination you need to be careful with. On the upside, this could mean you could lower the statin dose and still get the same therapeutic effect. All of that is something you need to speak with your doctor about. Combining berberine with other cholesterol-lowering agents like bempedoic acid and other PCSK9 inhibitors hasn't really been studied, so proceed with caution. A very interesting piece to the berberine puzzle is also its ability to modulate our gut microbiome. With berberine, we see clear shifts in the microbiome with less questionable gram-positive bacteria and more short-chain fatty acid producing bacteria. Increased short-chain fatty acid production is relevant because these small molecules are one of the main stimulators of natural GLP-1 secretion and have numerous effects on inflammation and immune regulation. We are just starting to understand how these shifts in the microbiome affect health, but berberine seems to be a positive influence. This is where you might hear that berberine is the herbal Ozempic due to its ability to increase GLP-1. But berberine's effect is not even close to the GLP-1 analogs. The change in GLP-1 secretion caused by berberine is not well understood, and natural GLP-1 is very short-lived. So don't take berberine expecting GLP-1 analog effects. Still, along with its other effects on metabolism, this is another positive shift in the body that will support a more healthy response in metabolic disease. Because berberine is poorly absorbed, a lot of researchers speculate that much of what we see with berberine is due to its effects on the microbiome. Future research will hopefully clarify that. Now on to something really crazy with berberine. it may be able to prevent colorectal cancer. At the very least, the evidence shows that it prevents the reoccurrence of colorectal adenomas, which can often become cancerous. What's even more mind-blowing is that taking berberine for 2 years seemed to offer protection for the following 6 years. Let me say that again. The subjects took berberine for 2 years and then stopped. And 6 years later, they still had lower rates of reoccurrence. Those are some pretty shocking results, so let's have a look at them. This study looked at 891 subjects with confirmed colorectal adenomas that received a complete polypectomy. The polyps were removed surgically. After the surgery, about half received berberine and the other a placebo. After 2 years, 36% of the subjects taking berberine had non-cancerous adenomas compared to 47% of subjects taking the placebo. That's an 11% absolute risk reduction. Very impressive. None of the subjects developed colorectal cancer in these 2 years, but it gets even better. Follow-up with these subjects 6 years later without taking berberine showed that the reoccurrence rate was 34.7% for those that had taken berberine and 52.1% for those that had taken placebo. That's right, the reoccurrence rate continued to drop. When looking at all colorectal neoplasms, berberine still had a suppressive effect 6 years later, with an occurrence rate of 63.4% versus 71%. Again, without taking berberine for 6 years. The mechanism behind this long-term effect is a mystery. The authors speculate that berberine may be selectively decreasing tumorigenic bacteria and that these changes persist. There could also be direct effects on tumor-promoting pathways. In vitro research has shown that berberine is active against many types of cancers. One important pathway in the context of colon cancer is our friend AMPK and SIRT1, which results in decreased NF-kappa B activity. As we learned in the albumin video, this results in less cancer cell survival and less inflammation. That's really just the tip of the iceberg with the preclinical research on berberine and cancer. I've linked a couple good literature reviews in the description if you want to dive deeper. The typical protocol for using berberine for metabolic effects and cholesterol lowering is to take 300 to 500 milligrams 2 or 3 times daily. The colorectal cancer study used 300 milligrams twice a day. There are some studies that have shown increased absorption when berberine is combined with medium-chain triglycerides, so a lower dose may be effective if you take products formulated with MCTs, but we still need more research there. If you're interested in trying berberine, purchase it from trusted supplement companies that follow GMP and that have standardized their material. I'm working on a video on how to buy good supplements, so look for that in the future. With berberine, the typical adverse effects are mild and include constipation, flatulence, nausea, and headache. The most common side effect is constipation, most likely due to changes in gut microbiota. If this occurs, lowering the dose usually helps. Also, berberine has been shown to inhibit cytochrome P450 3A4. So it's important to look out for drug interactions if you start taking it. In many cases, this can be accommodated by lowering the dose of the medication with your doctor's supervision, of course. That's it for berberine. What a ride. There's really so much that I didn't talk about, so dive into the research if you're interested. Are any of you already using berberine? What effects have you experienced? Let me know in the comments. Next up is colchicine. This one will be much simpler, but it's a good story to tell. Subscribe and turn on notifications to see when I upload that video. Until then, herb nerds.